start the second session here. We actually combined some of the stuff into the first session that I didn't want in the first session, but that's okay. We'll continue on, and we'll go ahead and retitle or re-describe this first session to start it with code. And we're going to just put in a timestamp here so that I'm aware of how long it took. And then we'll get started in the second session. So for the second session, what we want to do is, it's 37 minutes, I guess, not 47. Oh my lordy, oh my lordy. Oh yeah, that makes sense. Sorry. So for the second session, what we're going to do is we're going to review everything that we just did in the code, everything we should expect to see on the blockchain when we deploy the contract. Then we're going to deploy the contract using that migration that we created, which basically says just deploy the contract. We can throw other code in here too if we want for additional Truffle contracts, if there was more logic involved with the deploying. For instance, if we needed variables from the output of one contract to put in the second contract, we could do that all through the migrations. The contract that we created a little bit early in the live stream says that it's called election. It's going to have a constructor that goes ahead and makes the first and only variable equal to candidate 1. We're going to build on this obviously as we continue through the tutorial that we sourced, but for now what we want to do for this particular session is deploy this contract to the testnet, and then we're going to connect using the Truffle console and see if this variable is actually equal to candidate 1. That should take us not very much time, because all we have to do is go here in our console and run this truff migrate. And again, we ran into an issue last stream where truffle, the command, wasn't as expected. So we had to rename the bash script, or the batch script rather, that was inside of our app data folder to truff. So we're actually deploying this contract right now using the default amount of gas and like the wave value as well as the gas price that's in Truffle. And it'll just take a couple seconds to deploy this to the blockchain. Basically, we see a new block every 60 or so seconds, or maybe 20 seconds, 30 seconds. Depends on how fast miners are mining. I don't really know how fast that is inside of rinkeby, the testnet that we're using. But we're going to deploy that to the live net, the testnet right now. And we can see it in motion, deploying. But that's basically it. We were going to test this contract, but there were no tests available. Which actually leads me to one of the other streams that we're going to be doing later today, which is actually testing different Truffle contracts. So we're going to have to source contracts for that live stream and the next 3 days that makes sense to test. And Haley, can you remind me when we're about 7 p.m.?
Yep.
Sounds good, my friend.
So you said okay.
Yep.
You said a batch script. I don't really.
Yeah, that's just a series of commands inside Windows. So on Windows, you have these .cmd or .bat files, and the one that we just renamed is this one here. So if I was to open this in Notepad++, it shows you what it does. Basically, it's going to run Truffle for us, and it's got all this special commands in here to run Truffle. And again, Truffle is actually just a Node script. Like we were using Node in our last offline recording. Truffle is just built on Node. It's a Node library, and we installed it using the Node package manager. So when this command file runs, it runs all these codes here in the background to run our Truffle command based on what we feed it. So we just fed it migrate, which means it's going to do the migrate command inside of Truffle. And it's doing that as we speak. It's taking a long time though, so I think what we might do is we might go ahead and edit our Truffle file, this configuration file, with the gas prices we want to use, because I think we want to use higher gas than what it's trying to achieve or trying to use in the standard defaults. So let's just figure out Truffle.js migrate gas. Truffle gas price and gas limit on demand instead of using fixed. Well, that's not really what we want, but somewhere in here we'll have exactly what we're looking for. Not exactly what we're looking for, I guess. We want the gas price and the gas to use. So somewhere in here. Nah, maybe we can just use gas, I guess. So this uses a lot of gas. We have tons of test rinkeby ether to use. So if we use a whole bunch more gas than what the recommended or the example that we just found recommends, then we should be able to get a faster migration and a faster deployment. The other option is that my synced blockchain might be outdated compared to the real amount of blocks that are out there in the internet, and we'll debug that if we have to here in a sec. What's up? What's up, Henry? Yep.
So we're still using the ring, right?
Yep. Which is just a test net, like yeah.
I was just making sure that we're still doing.
Oh, yeah. I gotta see what's going on here. Why this is not migrating.
So how would you describe migrating? Is that just like transferring files, basically?
The migration that we're doing is basically, yeah, it's transferring the files. It's taking our local files and putting them on the blockchain. It's waiting for this transaction to be mined, I think. I don't know what's really going on or why this is taking so long. But we're trying to put the transaction onto the blockchain. So we're trying to publish this contract. And when we do publish a contract, it's going to put our source files, it's going to create the code, it's going to put it on the blockchain, and it's going to stay there indefinitely for the rest of the future, for the rest of the blockchain. If it works. I don't know if it's going to work. I wonder what we broke here.
And does gas represent money?
Yep, gas is the fee that's used to pay for stuff on the Ether blockchain. So if we were using real Ether here, we're not. We're using rinkeby Ether again, which is a test Ether. But if we were using real Ether, it would go ahead and cost us real money to do these deployments. Yeah.
Okay, so gas is basically a tax.
Yeah, it's just a fee that you pay. So you can pay higher or lower fees to get faster or slower transactions on blockchains.
Okay.
I wonder if I'm running parity, because I think I tried to launch it here before. It says somebody said that running parity in the background will cause this to fail. No, I'm not. Do. Somebody has 7 likes on running this this command in a different console. Oh, geez, my geth was stopped in the background. That's unfortunate. Let's try it now. Anyway, somebody said to run this command. Let's see if that helps. Whoops. Eventually, we'll migrate these scripts and deploy our contracts. Oh, we broke something. No suitable peers available. At least we have an error message now. Truffle, no suitable peers. Cannot deploy a contract in light mode. I wonder why. Here, Peter, stop me. Nope, it's fine. Back to our stuff here. Error, authentication needed, password to unlock. So we got to go back into geth rinkeby attach and run that personal unlock command again. Although I forget what it was. It's in here somewhere. One of these is what we're looking for. This one. No. Somewhere in here tells me what to do. I think it was just, oops. Oh, we need the right geth attach. Well, here's what we need. Jeez. Geth attach IPC. Geth attach IPC. Geth. Dash rinkeby attach. There we go. So now what I need is this guy here. The problem is this still might give us the no suitable peers problem, even if it does work after we unlock the address. So we might be back to exactly where we started, man. But it's a good thing because we needed additional time for this session, man. Oh man, personal. Oh shit. Okay, now we're unlocked. Let's try to run the Truff migrate again. Truff migrate. It says we have one viewer, but I don't think that's right. Let's refresh our page. Exceeds blocked gas limit. So we've used too much gas in my Truffle file. But that's a new error, which is good stuff. So let's go back here and remove some gas. We have 25 viewers, which is pretty good. Hi, everybody. And if anybody wants to give me a follow, they absolutely can. If they want to chat me, they absolutely can. We're deploying a contract to the testnet. Yay. So we got that past all those issues we were having, and we're now deploying using this transaction ID, which we could actually look up on Etherscan for Rinkeby if we wanted to, but we'll just wait until it gives us a contract. And then let's look up what we're doing next. So that's going to take a couple seconds to deploy. And then what we want to do is look up our guide here. We want to do Truffle console when we're done migrating. So we're a few steps ahead of where we were, which is good. So basically, my problem all along was that geth stopped working in the background. I just had hit C or like a letter on the program here, which is this one here. It stopped updating, it stopped doing everything that it was supposed to do. I had to relaunch geth and then re-unlock my account and then lower my gas limit in order for the transaction to work. So now, right now we're deploying. We can actually look this transaction ID up if we wanted to. Whoops, what'd I break? Do you have any questions, Haley? Oh, this one stopped. I had to put input into this window. I don't know, maybe we'll use Linux going forward because Windows does not like me. Anyway, here's our migrated contract. We're saving the successful migration to the network. We're deploying our election contract. Do you have any questions, Haley?
No, I'm following.
Okay, so we're deploying that contract we created earlier, which has got that one variable in there.
We're 2 minutes away from 7.
7 o'clock? No, that's 6 o'clock.
Oh, 6 o'clock, I'm sorry.
That's okay. Don't worry about it. You're fine. So we have our election contract on the blockchain. So actually, let's take a second to look at that election contract. We need to pull up another interface to the blockchain. We're going to use etherscan.io. We have 28 people in the stream. Congratulations, everyone, on joining us. Give us a follow, give us a follow. So really, I don't want to be using the live net here. How do I change the net we're on? Okay, let's actually just Google. I think it's rinkeby.etherscan.io. Rinkeby. Aha! Search for an account or address. So our contract was deployed rather on the rinkeby testnet, and here it is. Here's our contract. It was deployed 50 seconds ago from my account. Contract creation. We can look at the code. I guess we can see the op code, and we can see events that happened on this this contract, but there are none yet. So our contract exists. Here's the contract creator at this transaction. It's got no ether on it, no rinkeby ether. And now what we want to do is run, what was it, Truffle console? Truffle console. And go back to our guide here. So now what we want to do is, what are we doing? See if our access to deployed election contract, and we're assigning it to an app variable inside of a promise callback function. So after it looks at the blockchain and sees what's there, it's going to use an asynchronous call to save it to the app variable. And then we can actually look up the app.candidate variable. And we see that it's equal to candidate 1 right there on the testnet. We have our code that we created. It's saved to the testnet, and it's a public variable we can access. Anybody could access this by feeding Truffle the election code using the JSON ABI interface or whatever, and pull our candidate 1 variable. To tell you the truth, we could actually do that on my Ether wallet.
I have a question.
Go ahead.
What does dApp stand for?
Which?
It's like, you looked up earlier how to build DAPP on ETH.
Yeah, dApp. That's decentralized application.
Decentralized application.
Yeah, so basically it's an application that sits on top of our blockchain in order to, and that's what we'll do here in the next session actually, is start to build that decentralized application. So now that we have a blockchain, a smart contract on the blockchain, that gives us this candidate 1 variable. The next step we're going to do is build some JavaScript using Node to access this smart contract and just display it in a pretty way. That's all a decentralized app is.
Okay.
Yep. Now I don't know if I can access it in my Ether wallet or not, because I don't have the ABI or JSON reference, and I don't know how to look it up because it's not here in the code. Meh. It's okay, we don't have to look at it on my Ether wallet because we can see it right here inside of Truffle. Which brings us to the close of this session. So what's going on in our curriculum? So now we're going to start working on the client-side application. And really we want about an hour for each of our sessions. So we're coming up on the end of session 2, so hopefully we can last about an hour building our client-side application and talking about it. Otherwise, we'll have to add some more sessions or lessons inside of these sessions for us to be able to run for the full 5 hours we require. So everybody, thanks for joining us. Again, the learning objective here for this particular session was to deploy and then view the particular public variable that we had on the blockchain using Truffle. So, for everybody watching, we'll be back in about 3 to 5 minutes. I think we've been running long enough here to take a break. Yeah, just about. So hopefully we can spend a lot more time on our client-side application. Let's just take a preview of what we're going to do. Actually, we're going to add some more code to our smart contract. Well, that's good. We have a whole nother set of we actually have 2 things we could do here before client-side application. So let's change our curriculum here a little bit. It's funny because I was right when I originally wrote my curriculum, but oh well. So the next thing we're going to do then is work on the client-side application. Rather, the next thing we're going to do is some more further code in smart contract plus testing. Then we'll come back and work on the first bit of the client-side application. So the next few things that we're going to do are add how to add a candidate, how to manipulate the smart contract, how to interact with the smart contract using your Ether address. And then we'll go ahead and test all of that inside of Truffle using these assertions that we're going to create according to our guide. And then we'll go ahead and work on the next session, which is to start the interface. So basically, to answer your question, Haley, a decentralized application is like just a you know how like I don't know. You know how just applications and apps and websites and stuff exist, and they interact with the code, and they interact with the APIs and give you the data. So like whenever I send you a message on Facebook, it's sending it out to the API and sending that message via Facebook API, and then it's coming into you. So basically, Facebook is the application that sits on top of the Facebook API to give us all the Facebook stuff. So, and I shouldn't say Facebook on my live stream. I'm sorry about that. I hope nobody sues me. But otherwise, it's just an example of something that does something, and it's very popular. So
like they have different ones, like for your news feed, for your messages.
Yeah, different functions within the same application, right?
Okay.
But then you have Instagram, which is a whole other application. Then you have our decentralized application, which interacts with the blockchain to give you the stuff that's in the smart contract, which we haven't built yet. We're going to build an interface and like a pretty website and stuff. It's not going to be that pretty, but it'll do the trick. What other questions do you have?
So, geth account is that is the same thing as Solidity.
The geth interface here is a way that we can sync and talk with the blockchain. So first we have to get caught up with the blockchain and see everything that's already happened. The Solidity browser that we saw, which is the IDE, is already synced, and it exists on a website that's already synced with the blockchain, which is handy to have in some occasions. But for instance, you wouldn't want to do too much with your own personal web Ether accounts on there because they can intercept that communication. Then when we build our Truffle contract, that's kind of like building a contract in Solidity IDE, and they're both using the same code base, like the same way to talk to the blockchain, which is using Solidity.
Okay.
Yeah.
And
oh, you just zoomed in or something. What happened to your video there?
I didn't mean to.
I don't know what happened. That's just my computer being weird, I guess. There you go.
So, you said voting earlier?
Yep.
I was kind of.
So I mean, smart contracts can do a whole bunch of different things. They can you can interact with smart contracts to do stuff like lending ether or tokens, or you can do whatever you could possibly imagine on the blockchain. And one of the things that blockchains allow you to do is vote on different topics. So let's say you have like 1,000 people that you want to have access to your voting platform, and then you have like 3 different options that you want to vote on. So like candidates, or like different options you want to go, or different strategies you want to use, or like whether you want to build a new website or do a new app, or if you have a platform where you're actively changing your policies. Basically, you're going to want everybody involved in your platform to vote on stuff. So that's built into basically every blockchain, the voting capability in some way or another way. And in our case, we're going to vote on different candidates, which is basically like voting on candidates in an election, except ours are just made up.
I was just, so we're setting up all the candidates, right?
Yep, we're actually going to add a function here in the next session that allows us to add additional candidates using the web interface that we're going to create. But right now we just created it to have one candidate, which is called candidate 1. Where's my code? Here we go. So right now...
That was confusing me. We only set up one candidate for, and...
No, yeah, it doesn't make sense. You can't really vote on one candidate, yeah.
We're setting up more?
Yeah, we are. We're going to actually create a function to interactively create more without...
It runs through, like, I'm confused.
Runs through the blockchain. So whenever somebody votes, they have access using an Ether address, and they go ahead and submit a vote.
And, like, after they submit the vote...
It's counted.
It's counted and then...
Yeah, we're going to add all this code here and talk about it in the next section.
Okay.
Yeah. But you're right, that's exactly the next steps that we're looking to achieve, that we don't have yet.
Okay.
You're super smart.
That's all the questions.
Okay, sounds good. So what we'll do then is we'll take a 2 or 3 minute break. We'll come back with coding more good old truffle code in our contract, including, like I said, how to add candidates and count the votes and all that fun stuff. And we'll come back in just a few minutes to get that started. Again, the learning objective that we just covered is how to deploy and see the original public variable using Truffle. Okay, so we'll come back in 2 to 3. Goodbye.